Okay, we're going to wrap up section 1 of these college algebra videos by looking at a couple of more complicated linear equations here. I want to look at some rational equations, and rational equations are basically just equations that have fractions in them. Here you'll see that I have three fractions: minus 4 over 2x plus 3, 1 over x minus 1, and minus 3 over 2x squared plus x minus 3. Now, I wanted to factor this trinomial here because a lot of times when you have a problem like this, the factors will actually include denominators from your other terms. So it turns out that's the case here. So this factor contains 2x plus 3 and x minus 1. And since this is 2x plus 3 and this is x minus 1, then it means that I can use as my lowest common denominator just the product of 2x plus 3 and x minus 1. Now it is good to note that the domain is x cannot be negative 3 halves and x cannot equal 1. Because if you plug negative 3 halves into this expression, you would get negative 4 divided by 0, which is undefined. If you plug 1 into this expression, you would get 1 divided by 0, which is undefined. So just keep that in mind in case we were to get an answer that said that x was equal to one of those values. Now, since this is the lowest common denominator, I'm going to take each term. I have three terms here. Here's a term, here's a term, and then this over here, this big one, is also a term. I want to multiply each term by this lowest common denominator. So here I've taken the first term, and I'm going to multiply it by the LCD. And when I do that, the 2x plus 3's will cancel, and I'll get negative 4 times x minus 1. Now when I multiply the second term by my LCD, the x minus 1's will cancel, and I'll get 1 times 2x plus 3. You don't have to write the 1, but I just wrote it there just in case. Now, on the right side of the equation, if I multiply this fraction by 2x plus 3 times x minus 1, notice that not only the 2x plus 3 cancels, but also the x minus 1 cancels. And when I say cancel, I mean they equal 1. So I have negative 3 times 1, which is negative 3. So now I've converted this rational equation to a linear equation, and we can finish it by using properties we learned earlier. We can distribute negative 4 through here. Negative 4 times x is negative 4x. Negative 4 times negative 1 is plus 4. Here, 1 times 2x is 2x, and 1 times 3 is 3, so there's not much to do there. And over here I have negative 3, and I just bring that down. Now let's combine like terms. I have a negative 4x here and a plus 2x, so negative 4x plus 2x is negative 2x. And here I have a 4 plus 3, which is 7. So now I've got it simplified into a much easier term to follow. So now I have negative 2x plus 7 equals negative 3. And so what I need to do is subtract 7 from both sides, or just transpose the 7. It looks like I kind of did both there, but let's just say I subtract 7 from both sides, because if that's the case, then I left off the 7 here. So I have 7 minus 7, and of course those numbers are going to cancel. And then I have to subtract 7 from minus 3. So I have minus 3 minus 7. And now I have a negative 10. So on the left, since the 7's canceled, I have negative 2x, and on the right I have negative 10. And now you can probably do this in your head, because all you have to do is divide negative 2x by negative 2 to get x, and then take negative 10, divide it by negative 2, and you get a positive 5. So my answer is x equal 5. Now you can check this way back up here if you want to, but the main thing is we want to make sure that our answer didn't give one of these two numbers, because those are numbers that cannot be used. And since 5 is the answer and it's not negative 3 halves or 1, then our answer is a legitimate answer. Okay? Now this one's a bit longer, but basically it works like this. Here you have three denominators, you have 5z minus 11, 2z minus 3, and 5 minus z. And if you were to set each of these equal to 0 to see what would make them equal 0, for the first one you would get 11/5, for the second one you would get 3/2, and for the third one you would get 5. So our domain cannot contain any of those three numbers, or our answer. That also means our answer can't contain those numbers. Now, I'm going to take each of these three terms. This is a term, this is a term, and this is a term. So I'm going to multiply each term by the product of these. Now, it looks kind of nasty, but when you think about it, if you take the LCD and multiply it by the first term, then your 5z minus 11 is going to cancel, and you're going to have a 5 times the product of these two binomials. So we'll get to that in a minute. Just take it one step at a time, otherwise you might scare yourself to death. Now let's take this and let's multiply the LCD by the second term. Well, here the 2z minus 3's are going to cancel, which means they're going to equal 1. So I'll have 4 times the product of the first and the third factor here. And then on the right side, I take the third term and I multiply it by the LCD, and the 5 minus z's will cancel. And so I have a -3 here times the product of the two remaining factors. Now, this is where your intermediate or developmental algebra comes in. You're going to have to FOIL. So if you FOIL here, 2z times 5 is 10z, 2z times minus z is minus 2z squared, minus 3 times 5 is minus 15, minus 3 times minus z is, is minus z. Minus 3 times minus z plus z. Okay, and then here we have 4, and then we FOIL these two together. 5z times 5 is 25z, 5z times minus z is minus 5z squared, minus 11 times 5 is minus 55, and minus 11 times minus z is plus 11z. And then, on the right side of the equal sign, I have -3, and let's FOIL these together. I get 5z times 2z, which is 10z squared. 5z times minus 3 is minus 15z. Minus 11 times 2z is minus 22z. And minus 11 times minus 3 is positive 33. Now, again, one step at a time. Let's distribute the 5 through these terms. And I take that back. Let's simplify by combining like terms here first. Here I have minus 2z squared, but I can take 10z plus 3z and get 13z, and then the minus 15 is by itself. Same thing in this expression. I have minus 5z squared, and I have 25z plus 11z, which is 36z, and then the minus 55 is by itself. And then let's do it over here. I have 10z squared, then I have minus 15z minus 22z, which is minus 37z, and then the plus 33. Okay, now let's distribute. 5 times negative 2z squared is minus 10z squared. 5 times 13z is 65z. 5 times negative 15 is negative 75. 4 times minus 5z squared is minus 20z squared. 4 times 36z is 144z. Grab a calculator if you need to. 4 times negative 55 is negative 220. Over here, negative 3 times 10z squared is negative 30z squared. Negative 3 times negative 37 is positive 111z. And then negative 3 times 33 is negative 99. Now, notice here that if I were to take what I have left here and combine them, minus 20, I have minus 10z squared minus 20z squared, I get minus 30z squared. 65z plus 144z gives me 209z. Minus 75 minus 220 is minus 295. So it's getting to look a little more compact. I just brought down the right-hand side here, the minus 30z squared plus 111z minus 99. Now, let's transpose the minus 30z squared. That's all I'm going to do in this step. So transpose it. Move it to the other side. So I have minus 30z squared on the left, and if I move this minus 30z squared over here, it becomes a positive. And of course, now you're going to have a minus 30z squared plus 30z squared, which is of course 0. So all I have left on the left is 209z minus 295, and on the right I have 111z minus 95. Now let's do the little transpose trick. I have minus 295 on the left. If I move it to the right, it becomes plus 295. As far as my variables, on the right I have 111z. If I move it to the left, it becomes minus 111z. And now I just say 209 minus 111, that's 98, so that's going to be 98z. And then minus 99 plus 295 is 196. And then just divide both sides by 98, and guess what I get? Z equals 2. Seems like a lot of work for such a simple answer, doesn't it? Anyway, check it. Let's make sure 2 was not any of the numbers that are outside of my domain. So these were the numbers outside of my domain, and none of those numbers are 2, so I have a legitimate answer. Alright, I got one more I want to show you. This is actually a proportion, and with proportions you can cross multiply. Now a proportion is when you have a fraction on one side and a fraction on the other side of the equal sign. These were not proportions because I don't have a single fraction on each side. It only works when you have a single fraction on each side. So here I have a single fraction on this side and a single fraction on this side. When that happens, I can cross multiply. That means I can take the top from the left side of the equal sign and multiply it by the bottom of the right. It's just a little trick, quick little shortcut. So that's 5 times 3x squared. And then I can take 15x minus 1, the bottom from this side, multiply it by the top from this side. So I have x plus 1 times 15x minus 1. The order in which you multiply those doesn't matter. Now, the left side, 5 times 3x squared is 15x squared. If I FOIL this, and I'll leave you to do that, I'll get 15x squared plus 14x minus 1. Now, I'm going to take the 15x squared that's on the left, I'm going to move it to the right, and it'll become minus 15x squared. And guess what happens? Those are going to cancel. And then I have 14x minus 1 left. Now, so I have 0 on the left equals 14x minus 1. And then when I take the minus 1 and transpose it to the other side, guess what it becomes? A plus 1. And then to solve for x, just divide both sides by 14, and you get x equals 1/14. Now, the only thing that x could not have been in this problem was 1/15, because that would have made this denominator here equal 0. So 1/15 was the only number that I have to watch out for, and so here I don't have an issue because x is 1/14, not 1/15. Now, you might run across a problem like this where, let's say your answer was 1/15. Well, if that happens and you've done it correctly and you get 1/15 and you're not supposed to get 1/15, then what that tells you is that that solution will not work. And if that's the only solution you get, then you have a problem that has no solution, or possibly just no real solution, but you have a problem that has no solution if the only answer you get is an answer that's not in your domain of the problem. So that ends up, this actually ends the lecture on section 1-1, which is linear equations and linear inequalities.